So in today's class, we will speak about scope and lifetime of variables. So it's a very important concept, and you need to get a good hang of it so that you don't end up writing buggy programs. Not only that, you will, while writing programs, you design them properly from the scratch. So let's start with a program which computes mean and sum and squares of two numbers. So let's call this as mean.c. So yeah, let's see. We have two variables. Float a is equal to 10, b is equal to 20. So you want to find the mean of these two variables. Right? So you can say, you can define another variable called as float mean, and you can say mean is equal to a plus b by 2. And then you can say printf right? So when we compile this program, gcc mean.c, and so let me actually gcc mean.c. So now you can see the mean of 10 and 20 is 15, right? So it's an extremely simple program, nothing fancy about it. So, but let's say if you want to access if you look at, if there is another function, you want to compute standard deviation, okay, or variance. Okay, there is a function called as variance. So you want to compute the variance of the numbers a and b. Srijan already has a doubt. Tell me, Srijan, what is your doubt?
So can you tell us why in the last class's program it showed 3.14 and not 3.00? Like I still
I
need
am
to.
not able to hear you.
I'll type it out, sir.
Can you type it here, because the volume of my speaker has some issue. Okay. Yeah. So as Srijan, the question from the last class, I didn't figure the answer out for that, Srijan. So yeah, let me think about it, and we'll try to. I will post it to section A students also, so they may have some answer to it. So we'll take it up next week, Srijan. Rahul has something, so let's. We will take this up. Okay, so Rahul has something, and we will see. We will see. Okay. Okay, let's get back here. Do you know mean and so what is the formula for variance? Do you know the formula for variance?
Yes, sir.
What is the formula for variance? Can you type it down here, guys, so I can use your. I'm thinking the formula for variance is a minus mu square plus b minus mu square divided by 2. So let's say you want to compute the variance. So variance is some function mean of square of variables minus mean of okay, that's what you think, huh? Okay. Or let's say I want to, yeah, so mean of square of variables minus yeah, there are I think couple of ways to compute variance. So one way of doing it is a minus mean star a minus mean plus b minus mean star. Okay, this is some function. So if in case if some of you are not sure about what is happening here, don't worry about it. We are trying to compute some function of a. Is this okay? Is this? I think this is another way for computing mean. But the problem here is, in order for us to be able to compute the variance, in order for us to be able to compute the variance, you need to know the mean of the variables a and b. Yes or no? So there are two ways of doing it. Uh, One way of doing it is you can compute the mean again here. We can say mean is equal to a plus b by 2. So this is one way of computing the, we can say I have another variable float mean, and we can compute it again. But we are not happy about it because we are computing it again. This is one way of doing it. Another way of doing it is, since we have already, this is one way. So this is one way of doing it. You compute the mean and then again, and then use it while computing variance. The other way is you pass you know, uh, mean as a third parameter. So you want to call the variance function. So you kind of call the variance function like this, printf. So variance, so var is equal to, you can say variance a comma b comma mean. This is another way of doing it. Okay, so let's see. And is there a third way of doing this? Doing solving this problem? Yeah, so make mean global. So there is a third way of solving this problem, which is by declaring mean as a global variable. We will look at these three approaches one after another slowly and try to understand this idea of scope. Right? The first approach is, this is the first approach that we have taken. So the first approach where we have something like this. So this didn't work. This didn't work because the variable mean, which is declared in the function main, it is not available for the function. Okay. So here The if you see the variables a, b, and mean, so the scope of these variables is restricted to function main. The scope of these variables is restricted to function main. That means you can use these variables only in the function main. So the function, so the variable, let's if I remove this thing. So the variable mean, which is declared in function main, it is not accessible in the function variance uh, because the scope of the variable mean is within this function main. Are you all with me on this? The scope of the variables, local variables a, b, and mean is restricted to function main. This is the first important idea. And this is very important because when you are trying to and then the scope of the variable float is which is declared in variance is within this function variance. It is not accessible outside the function variance. This is very important to write bug-free programs because the variable mean which you declare here, if it is accessible in the function variance also, then by chance, you may end up overwriting it, and lots of bad things can happen. You may want to use the same variable but for a different purpose, and the program semantics gets clumsy. So as of now, you are writing small programs which consists of 3 functions, 4 functions max. But imagine when we are writing large programs, you may have hundreds of functions, and you cannot keep track of whether I have used this variable in some function or not. So all those things becomes hard. But by having this scope rule that local variables, the scope of local variables is the function in which they are defined, solves this problem nicely. All right. So if you want to communicate this thing, we can, so here A, B, but instead we can pass mean as a parameter to the variance function so that the value that is computed before can be used again. There is second important idea here. On line number 24, we are declaring a variable var, and this variable var is accessible within the function main, but after it's in the code which is written after its declaration. That is, it is declared on line 24, so it can be accessed from line 24 onwards. So the scope of the variable var is again restricted. It is restricted to main, but it cannot be used anywhere in the main. It can be used only after line number 24. That is from the point of its declaration. All right. So back then, maybe long time back when I was in undergrad writing C programs, the C standard at that time wouldn't permit declaring variables in the middle of the program. So this is not permitted. So I thought in C89, so there are different C standards. One is C89 and C99. I thought this is not this particular thing where declaring variable anywhere in the program. So this is not allowed in C89, but it is allowed in C99 is what I thought. Is this true or false, or what is the deal? So I thought this is the case, but when I try to compile the program, I'm not getting any bug. So when I compile this, GCC minus std is equal to C89, and huh, This comment is not allowed. Huh? Okay. But it is not giving any problem. So I don't exactly see uh, what's the issue. But otherwise in C89, it shouldn't be allowed. All right. Are you with me on the second point? So that the variable declared on line 24, it is restricted to main, but we can use it only after its declaration. That is the second point. Now let's take uh, so when while we are here, so and then but let's say if we have the global variable mean, okay, so the scope of the global variable mean on which is declared on line number 3, it is not declared in any of the functions. It is on line number 3, and it can be used in any of the functions. So it can be used in any of the functions. So we instead of passing it as a parameter, we don't even need to, yeah. So mean, and we don't. So now, if you see the on line number here, I want you to pay attention here. The mean that we declare here, so this is the same red mean. So when we do this computation, so we are assigning it to the global variable. And when we wanted to compute the variance on line number 25 by calling the variance function, we are using a minus mean plus star a minus mean, blah, blah, blah. So all these references to the variable mean, they correspond to this red mean. So the scope of a global variable is the whole of the file. You can use it in any function. Are you with me on this one? In the next idea, the scope of a global variable is the whole program. You can use it in any of the functions. Mm-hmm. Shantanu has an interesting thing. So let's see, Shantanu has a different point. We'll revisit what Shantanu is saying in a minute. Okay. So, but in any case, are you with me on this particular thing, the global variable? I hope you understand what this global variable means. So now, uh, I have a few interesting things here. Uh, so let's say on line number 18, so let's compile this program and see what happens. Okay, let's GCC. Yeah, let me remove this. So the average of the mean of 10 and 20 is 15. So it's all looking good. And let's look at the variance also. So let's compile the program again. So the variance of 10 and 20 is 25. Okay, great. So now let's do one thing. On line number 18, the local variable mean, which we are using before, I have commented it out. But let's say if I uncomment it now, if I compile this program and run, what do you think will be the output of this code, of this program? If I uncomment line number 18 and run it, what will be the output? Keshav says it's the same. Someone says it's an error. Error means is it a compiler error or redeclaration error? Jaishnav says compile error. Okay, let's see if there is a compile error or not. So there is no error here. Okay, there is no compilation error. There is no compilation error. But let's see what the output is. But if you see the variance now, the variance now is 250. It's not 25. Something is wrong. So Vitesh has this question: how can we declare two variables with the same name? So it is perfectly allowed to declare two variables with the same name. The only catch is this. So let's call this global mean as red mean, and I have this local mean as the yellow mean. So on line number 20, when we are when we are computing the mean and assigning it to this mean, so this mean refers to the local mean variable. This refers to the yellow mean. This does not refer to the global mean. So what we do is we go to the enclosing scope, which is a function, and see if there is a variable mean, and there is a variable mean, and that's what it gets assigned. But on the contrary, if you look at variance and this function variance, this mean is not present in the local, in its scope. There is no variable called mean in the scope of the function variance. So what happens is the mean that we use here is this mean. And all global variables by default, they will be initialized to 0. By default, they will be initialized to 0. So what happens is, since the value of a is 10, you have 10 square plus 20 square divided by 2, which is no 500 by 2. So we got 250.2. This is the thing that we got. Are you with me here? Tell me, Adarva, what's the problem? When you access a variable, you go to the enclosing scope, the compiler goes to the enclosing scope and tries to find, is there any variable in the enclosing scope? The enclosing scope for mean is this. The enclosing scope for mean is the main function. So within that, there is a definition or a declaration called float me. So because of that, this is used here. This is used. No, not the current value of mean. Yeah, so the global variable mean, it is all the time initialized to 0. So not an issue. So, and this value of mean gets used in the function variance. A global variable is initialized to 0 by default. So this mean gets propagated here, 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 and here. Did you get it, Adaro? Okay. So there is a good question. We cannot access the red mean in the function main. It's not possible. It's not possible to access the red mean in the function main. It's not possible. If you want to access the red mean in function main, you have to call the red mean some other name. Maybe you can name it as red mean. All right. Yeah, that's true. So that's true, Otherwise, you got it here. So now going on, uh, yeah. So let's say you are writing a loop, okay, for I is equal to 0, I less than 10, plus I. You want to compute sum is equal to sum plus I. So now you can see on line number 30, so on line number 31, so the variable sum is not declared, the variable I is not declared. So what you do is, no, here you put something like int sum is equal to 0. So now in the for loop, we say sum is a variable and it is initialized to 0. And the scope of the variable sum is restricted to the for loop. It is restricted to the for loop. And if you see the variable I, it is not declared. So what we can do is we can make int I is equal to 0. So now the scope of the variable I is restricted to the for loop. So the variables I and sum, they can be accessed within the for loop only. All right, this is what it is. Now, but you want to know at the end of the day, you want to say printf no, uh, mean of 0 to 9 is percent %f slash n sum divided by 10. This is what you wanted. So now you can see this sum is not available because the scope of the variable sum is this loop. One thing I want you to understand is a question I think someone in your class only asked last time, that the sum is inside the for loop. So every time you enter the for loop, doesn't it get initialized to 0? It's not the case. So the initial value of only what you are telling the compiler is two things. That the scope of the variable sum is restricted to this for loop, number one. Number two, when you enter this for loop, the initial value of the variable sum is equal to 0. These are the two things you are telling the compiler, and compiler sets up things accordingly. No, that's what exactly I'm saying. We are not declaring sum in every iteration. We are just telling the compiler that sum is a variable which is restricted to this loop only. You cannot use sum outside of this loop. And when you enter the sum for the first time, its value is equal to 0. Okay, right. So now because of that, you see that the sum is not accessible here. So we have to put here int sum. So that so when we put int sum here, so is this going to work? What will be the value? Now the error is gone. When if I run the program, what will be the value? What is the mean of these numbers? What will be printed? Garbage, yeah. So why is this garbage? Because on line number 29, sum is not initialized to anything. And so here again, this is what happens. So we have the red sum here and we have the yellow sum here. And what happens is the sum that we use here is the red sum. So the sum that we use, the variable sum that we are using to sum up in this loop is different from the red sum that we are seeing on line number 29. Yeah, this yellow sum has the values from sum of 0 to 9, right? So how do we solve this problem? So we make sum is equal to 0 and then we don't use the yellow sum, and now we are good. క్లాస్లో ఓకే. So, but Geet, the yellow sum is not accessible outside the loop. The variable yellow sum, it is not accessible outside the loop. Now, not now, earlier, when we have yellow sum inside, it is not accessible. So now you're all with me here. So in this program, let's compile this and see what we have. Okay. So you get no sum of numbers 0 to 9 is 45. 45 by 9 is 10 is 4.5. So we got it. So this is all about scope, and so you're all with me here so far in the class, in the lecture. So if you're all with me here, then we will move to the next idea, which is what is called as the lifetime of a variable. Shall we move to the lifetime? So that the theme for today's class is scope and lifetime. All right. So if you see this program so the function main calls variance. The function main, it calls the function main calls variance. And if you see the function main uh, has variables a, b, and mean. So you may have recalled from our discussion sometime back, there is what is called as a program stack. There is what is called as a program stack. And on the program stack, when a function is active, it's there is a what is called as an activation record associated with that function will be present. So if you look at the activation record associated with the function main, you will see it has fields to store the variable a, the fields to store variable b, and mean, etc. Sorry. And then, so how many of recall this idea of activation record program stack? We have seen it when we are working with recursive programs. So maybe you should revisit those lectures once. Uh, so now main calls variance. So when main calls variance, this is again the program stack, and on the program stack, so I'm now drawing it a little bit big so that we can see it clearly. So this is the activation record associated with main, and then there is an activation record associated with variance, and there the memory for the local variable var, and possibly the parameter, the space for the parameter variables a and b will also be allocated. So what happens is after we are out from the main, the activation record associated with variance will be popped out. So that means the life of the variables var a and b is gone. So the local variables that are present in a function, their lifetime is restricted to the timeline as long as no their lifetime they will be alive as long as the corresponding function is active, as long as the corresponding function is active. So when main calls variance, the variance function has become active, and then the variables associated with the function variance, their lifetime starts. And then once we are back from variance, once we are out of variance, then what happens is uh, the variance function is no longer active, and the memory that is allocated to the variables present in the variance function, that's all deallocated. So that is about lifetime. That is about lifetime. But if you look at the global variable mean, the lifetime of the global variable mean is throughout the program execution time. The global variable mean, the moment you start executing the program, the memory for the global variable mean is allocated, and that allocation remains throughout the program execution. So if you want to see this picture, so let's try to uh, yeah, let's put a breakpoint here. Let's try to debug this program. So maybe I will try to use GDB a dot out to enable break main run. So now if you see uh, right now on the program stack, so right now only function main is active, and on the program stack, the activation record associated with main is present, and the memory for the variables a, b, mean, no, where some, all these things are allocated on the program stack, on the activation record. Are you with me here? Yes, no? So main is active, and the lifetime of variables a, b, mean, where, some, all these are, they are all alive now. They have, their lifetime has started. So now we keep executing. So mean, ah, what happened? So let me get back again. So I want to run the program. Control L. So this is the activation. This is the current program stack. Maybe I should do next time. How do I step into a function? Or I have various different way of doing it. Let me do. Okay. So now we are on line number 25. So when we do BT full, this is the state of the activation record. And now we are in uh, in 5 in variance function, because main called variance. So if you do BT full, this is how the stack looks like. So on the stack, main is there. So main called variance. Within variance, the var is a local variable in variance. Now the activation record for variance is, the function variance is present on the stack. So the variables var, so these are alive. So this is alive, and this is alive, and this is alive. And also these variables a, b, mean, var, sum from main, they are also alive. Their memory is not yet deallocated. Are you all with me here on this particular idea? Yeah, the memory for the variables in mean, although they are not directly accessible from variance, they are still there. It is still allocated. It's important thing to note. All right. And then next. And then if I see, so now the memory for the variables in the variance function, it's all released. It's not, so their lifetime has ended. But if you see the global variable mean, there is a global variable mean. Right now, we cannot access the global variable mean from the function main because, because it is masked by the local variable mean. But the memory for the global variable mean, it is available throughout. Is allocated throughout, and its value can be accessed at any time. So to summarize the discussion here, so if you look at the program layout, so again, we have seen this before, but I want to recap this discussion. So if you, this is the main memory layout, this is the memory layout of a program. So here we have BIOS, and here we have the operating system kernel. This is a rough picture. And here we have what is called as a data section. And in the data section, memory for global variables will be allocated. And then we have a code section. In the code section, the program instructions are present. And then we have followed by that, so we have what is called as a heap, where memory for, when you allocate memory using malloc, calloc, etc., memory will be allocated from the heap. And then we have the program stack. This is the program stack. This is where the memory for the local variables will be allocated. So as you keep calling functions, etc., and the program stack keeps expanding, and as you return from functions, program stack shrinks. So this is how the whole program memory layout looks like. And the memory for local variables is allocated on the program stack. Are you with me here? Yes, no? Great. So now I have one last idea for today's class, which is interesting. And then after that, we can break for today. So let's clear all my drawings. Yeah, let's use a different program, static.c. So now I want you to write a program. I want you to write a program to which counts the number of. So you are calling some function, no, like in your, you have written some big program, and in which there is one function called as fun, and you would like to know how many times you have called the function fun. How can you keep track of that? You want to know how many times you have called the function fun. How can you keep track of this? So Desika has a nice idea that we can use, so something like int counter, which is a global variable, so you don't need to do anything about it, and you want to use a counter here. And then, like for example, I can say for int I is equal to 0, I less than 100 plus I call function fun, just like that. Yeah, do more stuff. So now GCC static dot c, and you can see that the function fun is called 100 times. So it's a good idea, but I'm not happy to make the variable counter global. How can I solve this problem? I don't want to use a global variable because if I have to keep track of how many times 100 different functions are called, I have 100 different functions, and so I want to know how each of these 100 different functions, or how many times each of these 100 different functions are called. Then I need to have 100 different counters. Okay, so is there any way to solve this problem without using a global variable? Pointer, right? How do you use a pointer, Dhruv? Just use counter in the for. Just use counter in the for loop. Huh? Pass counter as a useless parameter using, and then use a pointer, and then okay, got it. Yeah, there are a couple of ways uh, to do it. Like one way is like, for example, as Desika is mentioning, so you pass a counter as a parameter, no, as a pointer to counter, and then you increment it. So that is one way of doing it. Good idea. Another simple way of doing it, which kind of works, is you declare the local variable as what is called as a static integer. So when we make a local variable as static integer, the lifetime of the variable is throughout the program execution time. That is, even when fun is not active, the memory that is allocated to counter will still be there. So now, so when you enter the program for the first time, the counter will be equal to 0. And when you come call fun again, the counter value will be equal to 1. So it gets incremented, so on and so forth. So if you compile this program now, and yeah, so now you see an error that counter, it's a very interesting error. This counter is a local variable. This counter, it's a local variable. Its scope is here. This The scope of counter is within fun, but its lifetime is throughout the program execution. So since its scope is within fun, we are not able to use the variable counter here. We are not able to use the variable counter here. So maybe what we should do is we should do return counter, and then have something like uh, int count underscore fun. So now if you run the program, it works. So what is the most important idea here? The static keyword, what it does is two things. It extends the lifetime of the variable, local variable counter, to the whole program execution time. Usually when you call fun for the first time and then you call fun again, the local variable values will not be kept, will not be retained across function calls, because local variables are allocated memory on the stack, and once we are out of the function, the memory that is allocated on the stack gets deallocated. But when we make a local variable as a static local variable, then the memory for it will be allocated where? Can it be allocated on the stack? Can it be allocated memory on the stack? We cannot allocate it memory for it on the stack. So where should we allocate memory? We should allocate memory for it on the global section, on the global data section, where memory for all global variables is allocated. Not on the heap, Shantanu. No, not on the heap. Heap is managed separately by the malloc library. So we cannot use heap for it. If you recall the picture, if you have a global variable like here, int global underscore var, the memory for it is allocated in the data section. This is allocated for it in what is called as a data section. And this memory is alive throughout. But on the contrary, if you put allocate memory for counter on the stack, as soon as you are out of fun, the memory that is allocated, it will be deallocated. So you cannot put counter on the stack. So you have to put counter, this static local variable, in the data section. Are you with me here? Yes, no? This is an important idea, very, very important idea. This idea of scope and lifetime is very important. On line number 19, the return value from fun, it is just getting assigned to the variable count underscore fun. That's all. All right. So this is all I have for you today, this scope and lifetime. If you have any questions now, I will take them. Okay. Any other extra questions, any discussion you would like to have, I can take those questions.